So sometimes we will be dealing with a structure which is indeterminate and then hinahanap yung reaction at a particular location. So how do we deal with those kind of problems? We can use the force method para mahanap yung particular reaction na yun by utilizing the concept of deflection. Okay, so yung force method na to, or yung method of consistent deformation, this was introduced by James C. Maxwell in 1864. Essentially involves removing enough restraints from the indeterminate structure to render it statically determinate. This determinate structure, which must be statically stable, is referred to as the primary structure. The excess restraints removed from the given indeterminate structure to convert it into the determinate primary structure are called redundant restraints. And the reactions or internal forces associated with these restraints are termed redundants. The redundants are then applied as unknown loads on the primary structure, and their values are determined by solving the compatibility equations based on the condition that the deformations of the primary structure due to the combined effect of the redundants and the given external loading must be the same as the deformations of the original indeterminate structure. Okay, so it seems medyo confusing yung mga definition or description of the method that we have explained here. So it's better to apply them in a sample problem. So we are being tasked to find the corresponding reactions for this given figure. Okay, so we have two methods that we can employ here. We can just use formulas first. That is the easiest way to solve this problem. We can just use formulas for the reactions for a prop beam like this one. That's the easiest way. So you can just memorize formulas for common structures like this one. That's the easiest way to solve this problem. Kasi may mga formula na yan eh. What is the reaction that here, tsaka here, due to a uniform load. Kanya may mga formula na yan. You can just memorize those formulas. Okay? Or if you don't know, if you were not able to memorize those those formulas, you can just go back to the basics by using the method of consistent deformation. Okay? So, paano ba gamitin yung force method or yung method of consistent deformation for solving for the reactions of this type of structure? So, as you can see here, sa point B, sa joint B, yung deflection ng member natin, actual deflection niya is actually 0 kasi nga may support ka dyan. Okay? So, according sa force method, yung structure natin na to is actually equal sa isang structure na to loaded by the same load, pero tinanggal natin yung support dito at point B. So, parang naging cantilever na lang siya. Okay? So, kung naging cantilever na lang siya, pag niloadan mo siya ng uniform load, it will tend to bend like this. So, magkakaroon siya ng deflection at point B. Tawagin natin yung magnitude ng deflection na yon na delta B primary. Actually, itong structure na nabuo natin, this is what we call the primary structure. Okay? So, yung pag inad natin yung primary structure to this another structure, na ang load naman na kine-carry is yung supposedly reaction dito na BY. I-apply natin siya dito sa structure natin. Pag in-apply natin yung load na yon, supposedly the reaction at point B, tendency for the cantilever beam, it will deflect upward like this one. So, yung magnitude ng deflection na to, let's call that delta B redundant. Yung BY na yun, that is what we call the redundant. We have chosen BY as our redundant. Natatanggalin natin from the actual structure para mabuo natin yung primary structure. Okay? So, from the concept of method of consistent deformation, pag inad mo itong structure na to, dito sa structure na to, the result must be equal to this. Okay? Or in other words, yung deflection at point B, due to the primary structure, pag inad mo sa deflection at point B due to the redundant force or reaction, dapat yung sum nila will be equal to the actual deflection, which is equal to 0. Okay? Yun yung magiging goal natin for this sample problem. We just have to find the magnitude of delta B primary and delta B redundant, and then add them and equate them to 0. Okay? So we have several methods to find or compute deflections, but for this particular problem, I will just use the method of the virtual work method for the computation of the deflection. So, paano ba gamitin yung virtual work method na sa pag-compute ng deflection? So, kailangan lang natin mabuo yung mga moment equation dito. of M, yung capital M tsaka small m. Capital M will be coming from the primary structure. So, cut lang natin yung primary structure para mabuo natin yung moment equation niya. Cutting plane natin at a distance x from the right end. So, yung right side na lang yung ginamit ko kasi nga, pag yung left, meron ka pang kailangan computin na mga other reactions dito. Unlike yung sa right, wala ka na kailangan computin. Okay. So, yung moment equation dito, for the primary structure, I hope marunong kayo gumawa ng moment equation. It's just 24 times x, yung resultant nito yung nasa kanan, times the moment arm na x over 2. And take note downward yung force, so negative yung moment equation niya. Okay. For the redundant naman, same pa rin. Gawa natin ng moment equation. Yung cutting plane natin at the distance x pa rin from the right end. So yung moment equation dyan sa redundant will be the force times the moment arm, which is x. And upward yung force, kaya positive yung moment. Okay. So these are the moment equation from the primary structure. Okay. Next thing that we have to do is yung small m, yung moment equation due to a unit load. Okay. So copy lang natin yung structure natin, yung primary structure natin. Pero ang i-load naman natin ngayon ay unit load on the same location as the point kung saan natin kino-consider yung deflection dito. Okay? So usually yung direction ng unit load, usually the same yan sa expected natin na direction ng reaction. Okay? So kung expected natin na yung direction ng reaction ay upward, yung direction ng unit load natin, usually parehas na lang doon ng direction. Okay, so pag in-apply natin ng unit load yung cantilever beam, it will deflect. Ang magnitude ng deflection niya, we can call it delta beam due to the unit load. Okay? So yung deflection na yan can be also computed using this equation. Okay? So using that structure loaded by the unit load, we can compute for the moment equation. We can put a cutting plane at a distance x from the right end pa rin. So, dapat pare-parehas yung reference nila. Kung nasa right end yung reference mo, right end pa rin dapat yung reference mo. Okay. So, yung moment equation yan, multiply lang natin yung 1 sa moment arm na x. Yung moment equation na yan, that is our small m here sa formula natin. Okay. So, positive yung sign niya kasi upward din. So, pag nakuha na natin yung mga values na yan, all we need to do is substitute them dito sa equation natin, starting with the delta B primary. Delta B primary is equal to this, integral of small m, which is 1x, times capital M na negative 24x times x over 2, divided by EI times dx. Ang limits natin is from x1 to x2 is from x equal to 0, dito yung 0 natin, to x equal to 10 meters. Okay, kaya 0 to 10 yung limits natin dito. Kasi doon na naman nag-act yung cutting plane natin. Okay. So you can just easily solve this using your calculator. The answer will be this. Now in terms of EI tayo kasi wala namang given na EI. Sabi niya lang EI constant pa. Okay. Tsaka it's better rin naman na naka-EI ka lang kaysa substitute mo pa yung mismong value ng E tsaka I dito kasi later on maka-cancel lang din naman. Okay. And then take note nyo lang din yung sign negative. Ibig sabihin lang downward yung deflection natin, which is correct. Downward naman talaga yung deflection natin dito. Okay. Next, compute natin yung delta B redundant. Same formula pa rin. Same M pa rin. 1x. Ang mag-iba lang is yung capital M na formula or equation. It will now be byx divided by EI times dx. Yung limits niya same pa rin. 0 to 10 pa rin. Okay. So, from this equation, it seems like hindi siya integrable. Pero you have to realize yung by constant lang yun. So, pwede mo siyang ilabas ng integral sign and then i-simplify mo yung nasa loob ng integral. Pag simplify mo yung nasa loob ng integral, ito yung lalabas. And then balik mo na yung b1. Okay. So ito na yung delta B redundant, ito na yung delta B primary. Again, by the method of consistent deformation, dapat yung sum nila, yung sum ng dalawang deflection na yan at joint B dito, must be equal to the actual deflection, which is equal to 0. So in equation form, delta B primary plus delta redundant, or delta primary plus delta redundant must be equal to the delta actual. Substituting the corresponding values, delta primary, which is this, plus delta redundant, which is this, equal dapat to 0. So, by lang yung nawawalang unknown dyan. Nawawala na unknown pa. By lang yung nawawala dyan or yung unknown dyan. Yung EI cancel yan, obviously, kasi nasira yung right side. So, we can easily solve for by. By is equal to 90 kN. And that is already the first reaction dito sa sa given structure natin. Once na nakuha mo naman na yung By, since first degree indeterminate lang naman 'to, ibig sabihin meron pa lang kulang na isang, equation to be able to fully analyze it. Since 'pag nakuha mo na yung By is equal to 90 kilonewton, you can readily compute for AY, MA, tsaka AX. AX, zero lang din naman 'to, eh. So, ang kailangan mo na lang i-compute dito once na na-compute mo na yung By ay yung AY tsaka MA. You can just compute the other values using statics na lang. Okay, summation forces sa horizontal, I mean, summation force vertical, tsaka moment equal to 0. Okay? So, ito yung complete na reactions ng figure natin. So, pag kinomplete nyo yung vertical reaction dito, it will be 150 kilonewton, and then yung moment reaction, 300 kilonewton.